Dear students, welcome and thank you for tuning in to this video. I'm going to be continuing solving the problems of homework number 1 from chapter 1 for the statics class, the engineering statics class that I'm teaching. And we are going to be solving problems from chapter 1, which is the general principles chapter, in which we are going to be looking into simplifying numbers and writing the numbers and doing the calculations, making sure that we are representing them with the right unit system. For example, the one that we are going to be using in this class is the SI system, or the SI unit system, which is the System International. And we're going to be talking about the significant figures as well as the prefixes of the units. I'm going to be solving two problems in this video, 114 and 118 of the textbook, which is the Engineering Mechanics, Statics and Dynamics, written by Hebeler. And I'm going to be using the 15th edition so that you can follow with me. So I will start with so these two questions, actually, both of them are related into evaluating 2 or 3 significant figures and a group of numbers that have different prefixes, and also evaluating number that has multiplications and divisions into the simplest SI unit representation. So I will start with 114 and then I will do 118. So let's start with the first one, 114. It has 3 actually parts. So the question is, evaluate each of the following to 3 significant figures and express each answer in SI units using an appropriate prefix. And this is an important one because the representation of the prefixes is very confusing to students, and I would like to talk about this a little bit more. So the first problem that we would like to solve here is this. So it's 212 millinewton, right? And all of it is to the power 2, so that's squared. And that's an important skill that we need to learn, and important knowledge that we need to have about how can you do this if you are raising the units and the prefixes to powers, and then how do you represent the final answer if you have a unit to the power 2 or 3 or 5, and how we should be representing the prefix. So to solve this problem, I will start by trying to simplify it as much as possible. So I know that here for you the prefix and the unit, it's millinewtons. Remember, there are if there is a dot between the two, that means that it's meter. So there are 2 different units. So if you have m dot n, that means that you have 2 different units, meters and newtons. I don't have a dot in the middle, which means that this is milli. That's a prefix of that unit. So let me erase this quickly and then go back to the problem, solving it with you. Okay, so if I want to represent this in a simpler form, I will say this is 212 multiplied by 10 to the power minus 3. If you recall, that's the milli. And I'll put newtons, and then I will raise everything to power 2. So if you please use your calculator. If you use your calculator, I have now 3 things here to work with. I have the 212, 10 to the power minus 3, and the n. So I will raise each one of them to the power 2, because 2 can be distributed here. So this is going to be, it's going to be for you 212 square 10 to the power minus 3 all square, right? So you can distribute on the multiplication, multiplied by n to the power 2. Now, if you do the, continue with the calculation, 212 to the square will be, if you use your calculator, it will be 4. Let's do this, 9, and 4. Now 10 to the power minus 3 raised to the power 2, you can multiply now these two, minus 3 multiplied by 2, that's going to be 10 to the power minus 6, and you will end up with n squared. Let me make sure that this 6 is appropriate. appropriately written here, and so that we don't have any confusions. So this is going to be minus 6 newtons, right? Now, remember, we would like to be able to use this or to represent this number using the SI system, as well as we need to make sure that the final answer has 3 significant figures. This way here, what we're looking at now is that I have 1, 2, 3, 4, 5 significant figures. That's not what we're looking for. And also I need to make sure that I can use a prefix here as well, the appropriate prefix for n. Now note that the unit is to the power 2, it's square. And that's something tricky for engineering students to work with, but we'd like to make sure that we are covering all the basics so that you know how to represent this in the simplest form, an SI unit with 3 significant figures. So here's what I'm going to do. I would like to be, this is, if I'm going to put a decimal here, it's going to be my 0, correct? I will move the decimal to the left. Moving the decimal to the left, you can multiply the number with a 10. So if you move it 1 digit, you multiply by 10. You move 2 digits by 100. You move it 3 digits, you multiply it by 1,000. So what I will do this. I will say 44. I will move it 3 digits, 0.944 multiplied by 10 to the power 3 multiplied by 10 to the power minus 6 Newton square. So I hope that you're following that this 10 to the power 3 is coming from moving the decimal 3 points to the left, or 3 digits to the left. 3 digits to the left. Now, I'm still having here a 5 significant figures. So we need to make sure that we are going to have only 3 significant figures. So what I will do is that I will see if I can do rounding with the rightmost digit. So this is 4, this is less than 5, I can ignore it, and this is also 4, I can ignore it. Remember, the rule is that if the number is larger than 5, you can do the rounding. If it's less than 5, you don't do the rounding. And if the number, we're going to talk about this more. So I can say that this equal to 44.9. Now here, 10 to the power 3 and 10 to the power minus 6, I can add them together. And that will result in 10 to the power minus 3 Newton square. Right? So that's my number. Now here's the thing. In order to be able to, so this representation is the one that we are looking for, which is 44.9 multiplied by 10 to minus 3 and square. Now, some of you will be thinking, well, we can do 44, right, 0.9 milli-Newton square. That is not good. That's not a good representation. The moment that you have power for your the moment that you have a power for the unit of the system, we will actually avoid using prefixes, and we keep the numbers with their power, 10 to the power minus 3 or 10 to whatever that power is. I think this is the best representation and an engineering notation for such a number. So this one here is not good. We're not going to be using it. So I will erase that here, and your final answer will be this one. As we talked about before, for the final answer, we would like to have it in a box. So this is your final answer. So 212 millinewton square is actually 44.9 to the power minus 3 Newton square. Now you have 3 significant figures here, 1, 2, 3. You have a prefix, which is 10 to the power minus 3, and you have your unit to the power 2. The reason why we are not going to be writing a letter for the prefix is because then the unit is actually raised to the power. Right? It's not just Newton. And that's actually the SI representation. That's why I like this. So this is really a good example of how we should be doing this. Now let me do the second one here. So B. We're still in problem 114. So that is, let's just put 114 here just for your reference. So problem 114. The next number we will need to work with is, let's say it's 52800 millisecond, all of it squared. Okay, Same thing. I have here M and S. We have no dots between the two, so that's a prefix, so that's millisecond. So I will start by, similar to what we did before, I'm going to simplify this as much as I can. So I will say that this could be written as 52800, right? I'm going to be distributing the square to all of them, but we can do similar to what we did before. I can say that this is multiplied by 10 to the power minus 3, and you have S, and you can have all of them squared. You can now distribute the square onto all of these because it's multiplication, right? So I can say that this is 52800 squared multiplied by 10 to the power minus 3 squared multiplied by second squared, right? Same thing, we can now use our calculator. I will find out this. This is going to be a long number, the 52,800 squared. It will end up, if you use your calculator, it's going to be 278 7, right? Right, 278 7, and then we have 8 4, and I will have the zeros 1 2 3 4. Now multiplied by 10 to the power minus 6, if I'm just doing multiplying minus 3 multiplied by 2, and all of this is a square. Now here, what I can do, I will need to make sure that this is in a representation. This is the decimal here. I can do something similar to what we did up there. I can move the decimal to the left. Moving the decimal to the left, resulting in multiplying by 10 for each digit. And if you move to the right, you multiply by 10 to the power minus 1. So I'm going to be moving here 1, 2, 3, 4, 5, 6. So I will do 2787.84 multiplied by 10 to the power 6 multiplied by 10 to the power minus 6. Don't forget about that. And then you have s squared. If you do this, you can remove this with that, because you can add 6 to minus 6, that's going to be 0, and you will end up with 2787.84 seconds. Now, this second here, oh no, we forgot something. This is second square, correct? Don't forget the square of the second. Now here, what I will be doing for this problem is that this is still how many significant figures? It's not 3, it's 1, 2, 3, 4, 5, 6 significant figures. I would like also still doing another step by moving the decimal to the left and see if I can get, you know, a prefix here. So if I moved it 1, 2, 3, I can have it 2.787884 multiplied by 10 to the power 3, right? Second square. Now this number here is still 1, 2, 3, 4, 5, 6 significant figures. I need to do rounding here. So the rule of the rounding is that you keep, if the number to the right of the digit is larger than 5, you do the rounding. It's less than 5, you don't do the rounding. So this here is 4. We're not going to be rounding the 8 to its left, so I will remove the 4. Now the 8 can round the 7 here, so because it's more than 5, so I will delete this and move and do 8 here. And what I want from you is that you need to do digit by digit, right? So that's 8. How many significant figures? I still have 4. I need to have one more. So what I will do, I will erase this one here. I'll do rounding between these 8s. So it's more than 5. You erase this and you convert this to 9. And you do the 9. So I have 2.79 10 to the power 3s. Remember what we said before. We cannot actually because the second is squared, we cannot have a prefix. It's not the engineering notation. We will leave the 10 to the power 3. So what I will write it this way, 2.79. You can say this is 10 to the power 3, right? And second square. So you can, this is your final answer. You can have a multiplication like this one here between the number and the prefix, but you can do it as well this way. I'm fine with both ways. So the final representation of the 52,800 millisecond square is actually 2.79 multiplied by 10 to the power 3 seconds squared. So I hope that this is a helpful exercise. I have a quick one also here, the third one, C. And in C here, what we have is this. We have 5, 4, 8 multiplied by 10 to the power 6 here. And all of it, right, is multiplied to the power half. So that's a square. And we have milliseconds, right? So the way you do this is I would like first to distribute the half onto this multiplication, the 548 multiplied by 10 to the power 3, to the power 6, and then multiply everything with the millisecond. I don't have power for the ms here, but I can represent the millisecond with 10 to the power minus 3. So if I want to do this, I will say this is 548 to the power half. Right? We are distributing this power into the multiplication inside the brackets. And then I can put 10 to the power 6 to the power half and multiplied by 10 minus 3 seconds. So this is simplification. You can use your calculator to find the square root of 548, and that's going to be for you is 23.409. 10 to the power 6 raised to a half, which is square root of it. You can multiply 6 by 1 divided by 2, that's 10 to the power 3. So that's 10 to the power 3 multiplied by 10 to the power minus 3. Yes, don't forget the minus 3. Now these two can cancel because 3 plus minus 3 is 0. And you will end up with 23.409 seconds. Now this is 1, 2, 3, 4, 5 significant figures. We need to do rounding and have only 3 significant figures. So the 9 can be, the 0 can be rounded to 1 because to its right is the number larger than 5, which is the 9. So I can do that. So let's erase the 9 and erase the 0. And we can replace it with a 1, right? This is still 4 significant figures. This is 1 and this is 4. The 1 is less than 5. We can ignore it and we can just do the 23.4 in our rounding seconds, right? And that is our final answer for this. So if you have 548 multiplied by 10 to the power 6 to the power of half milliseconds, that's the mathematical or the SI unit or system representation with 3 significant figures of it. So I hope that this is helpful because this is important for engineering students to understand and be able to think and do the calculations of these things. As we said before, 3 significant figures, you need to have a box around your answer. If your unit, like this one here, is raised to a power, you don't put prefixes. You just put 10 to the power 3 or 10 to the power minus 3 here. If it's not with the power, then you can put a prefix with the milli and micro and all of these things. So that's the notation. Now let's move to the next problem, which is problem 18. And also this is another good exercise and practice. So in problem 18, so let me put it here, and so that we are following and tracking. So the problem is 118 from the textbook, which is the 15th edition of the engineering mechanics, statics and dynamics. So the problem says evaluate this number. So what we are looking at is they're saying you have 2, 0, 4, millimeters. No, let me write it in a much better format. Okay, so that it's easy for everybody to see. So what we can say, well, okay, this is 204 millimeters, right? Multiplied by 0.00457 kilograms divided by 34.6, yes, newtons. I need to put newtons there. So that's the problem, and we are putting here the Newton. Cool. So the question says evaluate this to 3 significant figures and express the answer in SI unit, using an appropriate prefix for it. So what I usually do in these problems, and this is important for all my students to consider. The first thing, you need to represent this in the simplest form that you can. So what I will do with this here, I don't like it this way. I will put it like 204 millimeters multiplied by 0.00457 kilograms, and then I will put the denominator 34.6 newtons. And then I will start simplifying it. I'm simplifying the prefixes. So this is the same as 204 multiplied by 10 to the power minus 3. That's your milli. And what I will do is that I will put the prefix, the units at the end. So I know that I will have an m here, the meter. And then I will multiply this by 0.00457. I'll put a dot, that's the kilogram, right? And you divide everything. See, make sure that you are doing this because that's important. That you have, when you have the dot between the m and kilogram, I know that this is meters multiplied by kilogram, it's not millikilograms, right? And then you divide by 34.6 and you put the newtons there, right? Now, you can use your calculator and do this calculation here. And when you do that with your calculator, and you can leave this later, to the right. So I can say this is m kilogram, right? Divided by newtons. That's meter kilogram divided by newtons. If you do the calculations here, you should end up with 20. M kilogram. So here, if you do the calculations, let me do that calculations because the number is going to be a little bit tricky here. So 204 multiplied by 0.00457 equals, you divide by 34.6, and that is going to be for you is this. I'm going to get the 10 to the power minus 3 on its own down here and do just the numbers, the calculations of the numbers. So I will say that this is 10 to the power minus 3, right? It's this one here. And if you do the calculations for the other numbers, you'll end up with this one here. So you will see 0.0269, say 44, right? Now, I would like to make sure that I can simplify this, correct? So the way to simplify it, this is 1, 2, 3, 4. There's a lot of significant figures. We need to have 3 significant figures. So what I will do, I would like to move the, see your decimal here, decimal point. If I'm moving to the right, you're multiplying with a 10 to the minus, right? 1, for example, for each digit. So this is 1, 2, 3. So let's do 26.944 multiplied by 10 to the power minus 3 because I moved 3 digits. And don't forget the other 10 to the minus 3. And then you have meters dot kilograms divided by newtons. Now 10 to the power minus 3 to the power minus 3, we can add them together and get a micro. Now see, all of these things here, the units, none of them has a power. So I can use a prefix for this unit, and I can say that this is micro meters dot kilograms divided by newtons. So I can get rid of these here. Now I still have the issue of the significant figures here. So 1, 2, 3, 4, 5. This is a lot of significant figures. But here's the cool thing. 4 is less than 5. It can't round the other 4. So I can cancel this and cancel that. And then it end up with 26.9 as my final answer. And that is actually how you represent this, or do the evaluation of this fraction for you in engineering terms. So I hope that this video helped you guys understand sorry, how you can evaluate fractions and making sure that you are using the correct engineering notation, you're using the SI unit representations accurately, as well as how to deal with the unit when it has a power. Thank you for watching, and in the next video I'm going to be solving 3 more problems in which we're going to do some convergence between the US custom system and the SI system, the system international. So I hope that you will be watching the video that I'll probably going to be leaving a link to it on this video. Thank you for watching. Until the next video. Bye.